Hey, welcome back folks. Gary Simmons here for the Game Institute. Let's get straight back into it. When we left off at the end of the last lesson, I was going offline to add some curves to the remaining core locomotion animations that are being used by my zombie controllers. And hopefully, in that period, you too have also done the same thing. And in a minute, I'm going to select some of the more interesting curves that I've added so you can compare them against the curves that you've added. Don't worry though, once the sound system is fully complete, I will give another version of this project away, so you will have a copy of the animations with all of the curves that I've defined. But I would definitely encourage you to follow along with me and add the curves yourself, because the curves system is going to be a very big part of many things that we do going forward, including the FPS arms and weapon system. And let me also be clear, when I say I have added the curves to the core locomotion animations, I'm really only talking about the animations that are used by the base layer and the lower body layer of my controllers. So if I select Jill's AI Entity Game Object and open up an animator window, with the base layer selected, I'm really only talking about things such as the idle, which in our case, we don't add curves to because we don't have any footstep sounds that are required by our idle animations. The left turn, the right turn, the sprint, jog and walk for both our base and lower body layers. In the base layer, we also have this subsection here to do with crawling. I haven't added any animation curves to this section yet. I will show myself doing that as and when we start defining the sounds for the crawling states. So when I went offline at the end of the last lesson, I needed to find all of the animations that are going to be used by my controllers so that I could add curves to them, and in some cases create some custom curves using that scriptable object class we created in the last lesson. Locating all of the animations that needed curves was thankfully very easy for me, because you will remember that going back either last lesson or the lesson before, I said that although we had created 4 animator controllers for our zombies, I was actually later going to delete 2, 3 and 4 because we're going to add so many scripts and settings to controller 1, it's just going to be quicker and more efficient for us to delete 2, 3 and 4, clone zombie controller 1 3 times and then just swap over the motion fields. But you'll notice I didn't delete these controllers, and that was because I wanted to keep them in the project for now because they contain all the information about which animations I had chosen to use. So for example, if I select Omni Zombie 3 and look at her jog locomotion, it uses a motion field called 12002, which is our gorilla walk animation, this one here. And you can see I've added a curve to that. Should we see what that sounds like? Well, let's call up Jill's AI Entity Game Object. Let's select her idle state in the base layer, because remember, we're just using Jill's idle state for now to test all of our animations. And I'm going to drag over that motion field from my gorilla walk animation. And when I press play now, we should hear her. Cool. You'll notice in the case of the gorilla walk animation, if we examine the curve, what I basically did was just use footstep sounds for the point where her feet touch the ground, but also for when the palms of her hand hit the ground right at the beginning of the timeline. And that sounded pretty good to me. So I was able to select my controllers, open up the animator window, and then just select all of the motion fields, find the animations that they're using, and make sure that curves were added to them. One of the interesting ones was the Pursuit 1 animation that is used by my second controller, which if I select, you will notice that this is another one of those pesky pre-baked animations, which means I can't add curves to it. So of course, what I needed to do was create my own custom curve. So if I select my custom animation curves folder, you'll notice that on top of the 2 animation curves that we created in the last lesson for Jill's damaged turn left and turn right, I now have this Pursuit 1 curve. So let's see what that looks like. So I'm going to select the Pursuit 1 animation. Then I'm going to select Jill, select her idle state in the animator, and drag over the Pursuit 1 animation into the motion field. Now, of course, if I press play now, we won't hear anything because this animation has no curves. There you go, look. But if I add my new custom curve, which I always name after the animation that I created it for, so I can easily see just by looking at the name which curve pairs up with which animation, we should see some sound now. We should hear some sound. Cool. This system is pretty flexible. I'm really happy with it. Okay, so for now what I'm going to do is I'm going to reset Jill's idle animation back to what it should be. Okay then, so our audio collection player script seems to be working perfectly, triggering sounds from audio collections in response to animation curve requests. However, as I discussed in the last lesson, we do have a problem where scripts will be executed on lower layers even if higher layers are active. And that means that we might be getting sounds triggered in our base layer, for example, when our lower body layer is actually overriding the animations because the scripts on the base layer are still going to be executed. And we need to put an exclusion system in so that for any state we can say we only want you to play this sound if one of the layers above me is not active. And we'll talk a little bit more about that in a moment. Now, just to demonstrate this, what I'm going to do is select Jill's AI entity game object, and I'm going to apply some lower body damage to Jill. I'll put her lower body damage at about 40. That's going to cause the lower body layer to become active, which means when she's idle, this idle animation should be playing here, which doesn't have a curve defined for it. But let's just say to test this on our base layer in its idle state, we'll copy over that gorilla walk animation into the motion field, okay? So what's going to happen here is when I press play, we're going to have that gorilla walk animation playing on the base layer. But we're not going to see it because the animation is going to be completely overridden by this generic idle state playing on the lower body layer, because the lower body layer is going to be active because we've given Jill some lower body damage. However, the audio collection player script on the base layer is still going to execute those requests to play footstep sounds in sync with the gorilla walk animation, and what you'll see is this. Now that's not good, is it? Now, this is a somewhat unrealistic example because, why would we ever have an idle animation where the character is running in one layer and an idle animation where the character isn't running in another layer? But, of course, what we might have is two idle animations where on the base layer, in the idle animation, the character is kind of falling around a little bit and could be wanting to make footstep sounds, whereas the one above it, the zombie may be perfectly static and not creating any footstep sounds. So although that was an extreme example, this is something that we have to worry about. Now, as I've said, one of the things that you can do is add a zero curve for the footsteps on any animations that doesn't use them. So the reason why this was happening was in our lower body layer, that idle animation doesn't have a curve defined for it. So the curve beneath it kind of has total control over the COM channel 1 parameter. Whereas if we had a curve defined in the lower body layer, then that curve would override the value that was being set by the base curve, and Unity would handle all of that for us. But I don't always want to be in a situation where I'm forced to add curves. So we're also going to add another layer of protection. We're going to allow our audio collection script to specify layers that should exclude that script from playing sounds. So in our base layer, for example, we'll be able to have a list where we say, we only want you to play your sounds if, for example, the lower body layer isn't active, and the attack layer isn't active, and the interactive layer isn't active, and the hit layer isn't active, and the cinematic layer isn't active. So in the base layer, we don't really want to play any sounds if any other layer is active except the upper body layer. The upper body layer doesn't make any sounds, and it also doesn't override the feet in any way. So when the upper body layer is active, that means the player has upper body damage, but the footsteps may still be getting triggered by the base layer or the lower body layer. So we never really use the upper body layer as an exclusion. One way we might do this, it would be to open up our audio collection player script in MonoDevelop, and maybe at the top add a new serialize field of type list string, which I'll call excluded layers, like so. So when I save that off now, and then wait for it to compile, and you'll notice in the audio collection inspector, we now have a list where we can specify a series of layer names. So for example, I might set that to 5 and just list the layers that I want to override this audio collection player. So we would say lower body, and the names of these would need to match the names of the layer exactly. Now, like I said, we don't want to have our sound stop playing if the upper body is active, because that's got nothing to do with our footstep sounds. And actually, we also don't want the attack layer to override us either, because the attack layer has an upper body mask on it. It's just working the arms of the zombie and the head. So in this case, the base layer may still be providing the sounds and the animation for the lower half of the zombie, but we would want it to override the interactive layer, the hit layer, and the cinematic layer. because these layers completely override the whole body of the zombie. So therefore any sounds played by any layers underneath it should be ignored. Now I've created that excluded layers list one too big, so I'm going to reduce the size of that list to 4. And then what we could do is have some code in there that basically just says, if I've had a request to play a sound, check with the animator, see which layers are active, and if any of the layers in our list are active, then do not play the sound. Just ignore the curve. And that's kind of what we're going to do, but the way I've set it up at the moment by defining a list in the audio collection player is a real pain, because we have a lot of states in our animator controller, and we're going to need to kind of do this for every state pretty much. I mean, even things such as the hit layer, for example, are going to need to have audio collection scripts on them that tell it to exclude those sounds from being played if the cinematic layer is active. So every layer is going to have an exclusion list for the layers above it that are supposed to cancel it out. And on some of those layers, that's a lot of states. And with each state, we would have to select it, define the excluded layers, and then type them all out. That would be error prone and a complete pain. So what we're going to do instead is we're going to define a scriptable object class that will allow us to store a list of excluded layers. And then what we can do is we can create a scriptable object instance for each layer. So we'll have a base layer instance, which just contains the list of all the layers that should be excluded by the base layer animations. We'll have a lower body instance that contains a list that is slightly shorter, that just contains the interactive layer, the hit layer, and the cinematic layer. And then we'll have an interactive layer scriptable object that really just defines the hit and the cinematic layer. And the great thing about this is once we've got the base layer scriptable object that just contains that list of layers that are to be ignored, we can just drag and drop that object with one reference assignment onto all of the states on the base layer. And it also means that if we add other layers further down the line, we don't have to go back and insert a layer into this excluded layers list on every state, on every layer. We just update the scriptable object. So let me first of all go back to my audio collection script and let's remove that horrible list of strings that I just added. And what we'll do is we'll create a scriptable object to do this instead. So I'm going to drill down into my scripts folder and into my scriptable objects folder. And I'm going to create a brand new C# script, which I'm going to call string list, because really this is just going to be a generic holder for a list of strings. Then I'm going to open that up in MonoDevelop. Okay, so as this is going to be a scriptable object and not derived from MonoBehavior, we can get rid of the start and update functions. They have no sense in this context. And of course, we also want to change the base class from MonoBehavior to scriptable object. This class is going to need a single serialized field, which is going to be a list of strings. I'm going to call this string list. Because this is a serialized field, it's going to show up in the inspector of the scriptable object, allowing us to resize the list and add strings to it via the editor. So all we really need then is a getter so that we can, via script, fetch one of the strings from this list. And what I'm going to do, much like we did with our audio collection class, is I'm going to implement the indexer property. So I'm going to create a public property that returns a string. And you'll remember that in order to implement the indexer property, we do it like this. We say this, followed by square brackets with int I in the middle of it. And of course, this property just needs a getter. And all it really is going to do is just fetch element I from string list. But we need to make sure that I is within range of elements defined in our list. Do a little bit of checking. So we'll say, assuming that I is within the range of the number of items defined in our list, well, then we will just return the element that is stored at that index in our list. If the index passed in is out of range, then we'll simply return null. That's our scriptable object done. But we also want to add that create asset menu attribute so that we get a chance to create instances of this scriptable object from the assets menu inside the editor. And I'll set the file name property of the create asset menu attribute so that any scriptable object instance we create is initially given a default name of new string list. And if I save that off now and go back to the editor, we should be able to see that when we go to the asset menu and the create submenu, hey look, we have the option to create a new string list. So I've just created one temporarily there. You can see it's called new string list. And if I call up the inspector, you can see it's nothing more than just the ability to define a list of strings and then type in the names of those strings. So we now have the ability to define the layer exclusions that are going to be used by the animation states on each layer of our controller. So we can create a string list for the base layer, which is going to contain the lower body layer, the the interactive layer, the hit layer, and the cinematic layer. And then we can create another string list for the lower body layer, which is just going to check that the interactive, hit, and cinematic layers aren't active. Then we'll create another string list for the interactive layer, which is just going to have 2 elements to check that the hit and cinematic layers aren't active. And finally, we've got one for the hit layer that literally has a single element, which is just, it's not going to play its sound if the cinematic layer is active. So let's delete that new string list that I just created temporarily, and let's find, where am I going to define my string lists? Well, I think what I'm going to do is I'm going to create a subfolder in my Dead Earth folder, and I'm going to call this string lists. Inside the string lists folder, I'm going to create another folder called layer exclusions, and inside the layer exclusions folder, I'm going to create another folder called zombies. And that way, I know that irrespective of how many string lists I might create in the future, I know that if I'm looking for a string list that is to describe layers in a zombies animator, then this is the folder I need to come to. So I'm going to create my first string list now that's going to be used by our application. So I go to the assets menu and I choose from the create submenu to create a new string list. And I'm going to call this base layer. I'm then going to go to the asset menu again and create another one. I'm going to call this lower body. Yeah, actually, I'm not going to call the first one base layer. I'm just going to call it base. Now, I was going to say we don't need one for the upper body layer, but actually that's not true. We might. It depends. We don't need one to block out footsteps, but we could have a situation later where our upper body damage animation is making a noise with its upper body, and that's going to be overridden by the attack animation, which is going to have the zombie's arms swiping at you. So we probably do want to have string lists defined eventually for all of our layers. So I'm going to create another string list. I'm going to call this upper body, and I'm going to create the rest of these now as well, one for each layer. So with my layer list selected, let me select the base layer. And of course, the base layer needs to not play its sound if the lower body layer is active. We don't have to worry about the upper body or the attack because those 2 layers are only animating the upper body and don't affect the footsteps. In fact, we very often want our footsteps on the base layer to play when the attack layer is playing because our base layer is providing perhaps the running animation. But we do need to check the interactive, hit, and cinematic layers. So we actually need 4 elements in our base layer list, and we just then have to list the layer names, and the capitalization, white space, and spelling needs to be exactly what you named the layers. So the first layer we need to check is the lower body, the interactive, the hit, and finally the cinematic. And that's the layer list defined for our base layer. So let's now fill out the lower body layer. That needs to have 1 less element, of course, because it no longer has to check if itself is active. So the lower body layer is really just checking the interactive, hit, and cinematic layers. Like so. And then of course we want to create one for I'm going to leave the upper body layer string list for now because we don't actually need it at the moment. But I've defined it just in case we do when we start adding curves, if we start adding curves to the upper body layer. But I don't think we will, but I've defined it so it's there just in case we need it. So the next thing I need to create is the string list for the attack layer. The attack layer is going to need to check the 3 layers above it. So it needs 3 elements: interactive, hit, and cinematic. Next, we'll define the interactive layer, which of course just needs to check the hit and cinematic. So it needs 2 elements. The first one, hit. The second one, cinematic. Once I spell it right, of course. And that's all the string lists that we need now. They're all defined. We obviously don't need a string list for the cinematic layer. Oops, I didn't define one for the hit layer. I forgot to do the hit layer. So the hit layer just has to have 1 element in which it ignores the cinematic layer, because that's the only layer above it in the stack. Okay, so our string lists have now all been defined. So what we need to do now is go back to our audio collection player script. Remember, that's the script on our states that actually plays the audio clip from its assigned audio collection. And we need to declare a variable now of type string list. So let me go back to my audio collection player class. And remember before, when we were testing this out, we defined a list of strings. We've now replaced that list of strings with a string list. And we'll call this variable layer exclusions. And we'll set that to null by default. Save that off, go back to the editor. And of course, it now means that in order to tell this animation state to ignore all of the layers above it, we no longer have to type a great big list of all of the layer names. We just select our base layer and drag it into the layer exclusions list. Now, of course, our audio collection script doesn't do anything with this yet. We now have to implement the code that is going to, when it gets a sound request, check if any of its excluded layers are active. And if they are active, then ignore that sound request, otherwise play it. And that's not quite as simple as it might seem. And that's what we're going to do now in the next section. So things would be quite simple if the single criteria for a layer being active in our system was simply that the weight of that layer was greater than 0. If that were the case, then all our audio collection player script would need to do is loop through the list of layers in its string list and use the animator's getLayerWeight function to inquire about the weight of each layer. If the weight of any layer in its string list was larger than 0, then we would know our audio collection player would not need to play its sound. Unfortunately though, in our system, the criteria for whether a layer is active or not is slightly more broad. In fact, only our lower body layer uses the layer weight system at all. All of the other layers always have their layer weight set to 1, and we use empty animation states to essentially nullify that layer when nothing interesting is happening on it. Therefore, we need a system that can determine if a layer is active not just purely based on its weight, but also based on what animation is playing on that layer. Now, we could put code in our audio collection player script that queries the layer to see if it has a state on it called empty. And if that's the one that's currently playing, then we know that it's not an active state. But this is really messy. It relies on us always having a state named precisely empty. And you can see even how we've got ours set up at the moment. On the attack layer, we called this state empty state. On the interactive layer, we called it just empty. On the hit layer, we called it new state. Cinematic layer, we called it empty state. So we don't want to do that. We want something a little more versatile. Fortunately, we've already developed a system that, if expanded, can handle this. You will remember that there are several places where our AI state machine and the derived AI zombie state machine class need to know whether the cinematic layer is active. One example of this is if we wish to play a scream. We don't bother screaming if the cinematic layer is active, because obviously the cinematic layer is supposed to override the screaming layer, or the interactive layer, the layer that the screaming animation is on. Another use for knowing whether the cinematic layer is enabled or not in our state machine is when the zombie has been hit and is taken damage. If the cinematic layer is active, we always ragdoll the zombie because we just don't have the prerequisite reaction animations from any of the given states that our zombie may be in on that layer. So you will recall that what we did is in our state machine class, we had a boolean called cinematic enabled. And in our cinematic layer, we have this script called cinematic enabler. And we added that to the empty state. If we open up the cinematic enabler in MonoDevelop, you will remember that we can configure whether this script sets the cinematic enabled property of the state machine to true or false, either on enter, on exit, or both. So in our particular case, what we did is because we put it on the empty state, we wish the cinematic enabled boolean of our state machine to be set to true when we exit this state. So that's why in the inspector of the cinematic enabler, we've put a tick in the on exit boolean. In other words, when we exit this state, we contact the state machine and we set its cinematic enabled boolean to true. Of course, we've only done this for the cinematic layer. What we need is something that can do this for all of the layers. So we want to take this system and expand it. So instead of having a cinematic enabler script, why don't we just have like a layer enabler or a layer activator script? And in our AI state machine, instead of having a single boolean to keep track of whether the cinematic layer is enabled or not, why don't we have a list of boolean, or even better, a dictionary of booleans that are keyed on layer name, so that we can have a boolean that describes the active state of every single layer. In order to do that, we'll need to add some code to our AI state machine, and we'll need to remove references to the cinematic enabled property in our AI state machine and our AI zombie state machine. So let's do that now by first of all removing the cinematic enabler from our empty state in the cinematic layer. Then what I'm going to do is I'm going to select that script. Remember, it's in the scripts AI state machine behaviors folder. And for now, I'm going to duplicate it. I'm then going to rename this layer enabler. Our cinematic enabler script will not be used anymore. We can delete it. We will never use it again. We are going to use the layer enabler script instead that will not just deal with the cinematic layer, but will deal with setting the active states of all layers. Let's open up the layer enabler script in MonoDevelop. First of all, we need to change the name of the class. We're going to call this layer enabler, like so. And then what we need to do is we need to change the code that sets the cinematic enabled boolean to either true or false depending on the two boolean properties. Let's imagine that we've created a function in our state machine called setLayerEnabled, because that's exactly what we're going to do in a moment. And let's say that this function takes two parameters. The first is the name of the layer that we wish to set a boolean for, and the second is the state of the boolean. So as the first parameter, we'll pass in the name of the layer on which this script is activating, and of course that has been sent into us via the onStateEnter parameter list. Now we've got the layer index, but in my AI state machine I think I'm going to want to store the booleans based on layer name. But that's no problem because our animator has a getLayerName function where we pass in the layer index, something that we do have, and it will return to us the name of that layer. And for the second parameter, we pass in whether the layer should be enabled or disabled, and we configure ours. Because we put this script on the empty state, we actually wish onEnter to be false, so that when we enter this state, we are saying that the layer is not active because the empty state is currently active, and we set onExit to true in the inspector so that when we exit this state, we know we're transitioning out of the empty state into a proper animation, and therefore we are supposed to consider this layer as being enabled. So of course we need to make that change down the bottom as well. So we'll say state machine set layer enabled. Once again, getting the name of the layer by using the animator function and passing in our layer index that were passed into this function by Unity. This time we pass in the onExit boolean, and that is our layer enabler script done. Now of course it's giving us errors at the moment because we have not implemented the set layer enabled function in our AI state machine, so we're going to need to do that next. But that is the script done as it is at the moment. Now if I go back to the editor, I'm guessing it's not going to allow me to add this behavior. No, it's asking me to fix the code. So we can't actually add this script to our empty state yet. We're going to go and need to fix up our AI state machine class, get rid of that cinematic enabled boolean and replace it with our dictionary of booleans and some functions that allow us to set and get the state of any layer. So I'm going to go to the AI folder inside our scripts folder, and I'm going to open up our AI state machine class. And the first thing I'm going to do is I'm going to scroll down to where we declare that protected boolean called cinematic enabled, and I'm going to delete that from our class. This is going to create lots of errors in lots of places, but that's good because that will allow us to easily find where we reference that boolean and can replace it with a code that's going to use our new system. What we're going to do instead is we're going to add a new protected dictionary that has a string as a key, the layer name, and a boolean whether that layer is active or not. And I call this animLayersActive. This dictionary of booleans will allow us to keep track of the active-inactive state of each layer in this AI state machine's associated animator. So let's now scroll down to where we used to have that property defined that would return or set the value of the cinematic enabled boolean. Let's get rid of that cinematic enabled property. We no longer need it. We're going to create two functions now. One of them is going to allow us to set a boolean in our dictionary, and the other is going to allow us to retrieve the state of a boolean in the dictionary. So the first function we're going to create is the one that we've already seen us trying to call from our layer enabler script. That's the set layer enabled function. This has a void return type and takes two parameters. The first is the name of the layer we would like to set the status for, and the second is the status, whether it's active, true, or inactive, false. And of course, all we need to do then is we need to set a key with layer name in our animLayersActive dictionary and assign its value to the boolean that was passed in, so either true or false. So this function can be used to enable or disable the state of a layer. And of course, what we're also going to need in a moment when we're processing our string list inside our audio collection player script is we're going to need a way to inquire about whether a layer is active or not. So we'll create a function called isLayerActive where we pass in the layer name as a string, and we simply get returned a boolean describing whether the layer is active or not. We use our animLayersActive dictionary's try-get-value function just to see if the layer name that was passed in does exist within our dictionary, and if it does, then what we get back is this boolean result, either true or false. And we return that result. But if the key doesn't exist in our dictionary, we simply return false. So now we have a layering system inside our AI state machine that our animator can use to both push values into and fetch values from this animLayersActive dictionary. However, before we carry on, we need to now go down and find where we have some errors, where our code is still trying to use the cinematic enabled boolean. Okay, so we don't have any in our AI state machine, but I think we do have some in the derived class, the AI zombie state machine. So let's open up that script and let's find the errors. Here you go, cinematic enabled. So of course, what we want to do now is we want to change that to use our function. Instead of saying or cinematic enabled, we want to change it to isLayerActive. and pass in the name of our cinematic layer, like so. In that case, you can see this is in the screen function, where we say if the animator is null, or if isLayerActive cinematic is true. In other words, if our cinematic layer is active, then we return false and we don't perform a scream. If I scroll down to the update function in our AI Zombie State Machine, you can also see that it's being used again here to determine whether we're screaming or not, because this is used to pass in a value to our animator, the screaming hash, to actually trigger the screaming animation. So once again, we will swap that Boolean check out and instead use our isLayerActive function, passing in the exact name of our cinematic layer. And I think we also do a check when we're determining whether we wish to ragdoll our zombie. Yes, we do. Inside the take damage function of our AI Zombie State Machine class, you can see that we say if we're currently not in an animated state, or if we're crawling, or if our cinematic layer is enabled, then we should always ragdoll. So once again, we just want to check that and change that to isLayerActive. And then pass in the name of the layer we wish to check, which once again is our cinematic layer. I don't think we do any more tests for cinematic there. No, I don't think so. So I think we've caught everything there. Okay, so let me compile. I'm actually getting an error in my, in my layer enabler class. What have I done? Have I called the function something else? Yeah, I called it setLayerActive, which to be honest, I like better. So I'm going to change the layer enabler state machine behavior to use setLayerActive instead of setLayerEnabled. Okie dokie, so let me go back now and check that we have no errors. And everything is cool. So now what we can do is in our cinematic layer, we can select the empty state and we can choose to add our layer enabler script and just configure it so that we want it to set the cinematic layer enabled when we exit it. And in fact, we can now add one of these scripts to every empty state in all of our layers, right? Because that script automatically takes the name of the layer. We don't have to specify it. And then we'll know whenever anything other than empty state is playing on a layer, the AI state machine will correctly have a Boolean stored for whether it is enabled or not. And we'll do that on the attack layer as well. So you can see that little cinematic enabled Boolean system that we created before has been greatly expanded now, and it can be used with all of our layers with absolute ease. Now we don't need to put this script on any of the states of our upper body or lower body layers because these layers are kind of anomalies compared to the rest of the system. They don't have empty states that are running on them. They're activated when their layer weights are set from 0 to 1. And currently, our system doesn't handle that. It only handles setting a Boolean when we transition into or out of a state. So for our lower body and upper body layers, we're going to have to do something a little bit different inside our AI State Machine class. And we're going to have to just keep track of what these weights are and set the active state manually inside the AI State Machine itself. Now, hopefully you will remember that in our AI Zombie State Machine class, we have a function that we call when pretty much anything changes in the animator, and it's called update animator damage. Here it is here. And this is where we set the layer weight of the lower body and the upper body layers based on how damaged the player is. So you can see we set the layer weight of the lower body layer by saying if lower body damage is larger than the limp threshold, but our lower body damage is smaller than the crawl threshold, then we're going to set the weight to 1, otherwise we set it to 0. So as this is the code that sets the layer weights to 1 and to 0, this is where we know whether the lower body layer is active, and we can just manually set the state in our dictionary here. So just at the bottom of the function, I'll say if lower body damage is larger than limp threshold and lower body damage is smaller than crawl threshold, then set layer active, lower body true. So we've manually set this. Otherwise, set layer active, lower body to false. And I suppose really we should do this for the upper body as well, even though like I know for a fact based on my animations that I'm never going to be using that. You may in your animations. So I better just put the code in that handles this by saying if upper body damage is larger than upper body threshold, And if lower body damage is smaller than crawl threshold, we still wish to do that test, then we will set the boolean for the upper body layer to true, otherwise we'll set the boolean of the upper body layer to false. Remember, when we do the test for the upper body to see whether we've got upper body damage and that damage is past the upper body threshold, we still test the lower body damage is smaller than the crawl threshold, because if we're crawling, we also don't want to use the upper body animation. So that's why that code is here like that, and we also have it up there where we're deciding when we set the layer weights. Okay, so if I save that off now, go back, check we haven't got any errors, and we haven't. So what we should see now is, if you remember, before I assigned that base string list to our idle state on the base layer, when I pressed play, we were getting this. Now remember, that's because we currently have given Jill lower body damage, so she's playing the idle from the lower body layer. But the sounds are still being triggered from the idle on the base layer. So we can now use our string list to stop that happening. So let me select Jill. And on the base layer with her idle state selected, let me assign as her layer exclusions that base string list. And just to remind you, this is the list that excludes the lower body layer, the interactive layer, the hit layer, and the cinematic layer. Actually, I mean, obviously I haven't implemented the code to check this list yet. We're going to do that in a moment. But I have just had another thought as well. There's something that I have forgotten to add to our string list scriptable object. Although we have the way to access any string in our list, I also need to create a property that's going to allow us to inquire how many strings are in the list so that we can set up a for loop to iterate through each one. So I'm going to create a public property that returns an integer, and I'll call this count, and it'll have a getter, and that getter will simply return the number of elements in our string list. So we'll say string list.count, like so. Forgot to do that. Very important. There'd be no way for me to know how many strings were in this list without that, and be able to set up a loop to iterate through it. And now let's open up our audio collection player and write the code that's going to iterate through that list and return without playing the sound if it finds any of the layers in the list that it's been assigned are active. So we'll first of all check we have been assigned a string list. So we'll say if layer exclusions doesn't equal null, then we'll set up a for loop to iterate through each string in our assigned list, and we're going to use that count property that we just created to get the number of strings in our list. And then inside the loop, we'll simply say if state machine is layer active, and we'll just pass in the name of the string that we've just fetched from our string list by using that indexer property. We're saying layer exclusions, passing in our loop variable I. And if that function returns true, then we know that this layer is currently active. So we will simply return from this function, and we will not do any other processing here. If I save that off now, I think that should do the job. Okay, so let's press play now, and let's see if the sounds that were being triggered from the base layer are now being correctly stopped by the base string list that we've assigned. Hey, there you go. And let me just to double check this definitely works. Let's select the idle state on the base layer. Let's remove the layer exclusions and press play again, and we should hear the footsteps again. Cool. Okay, so that was a little bit tricky, wasn't it, getting that to work? But everything is now working fine. We now have a way for any state machine behavior script via the AI state machine to ask if any other layer is currently considered active, be that activated via layer weight or activated via a non-empty animation state playing. So now that we've done that, I'm going to select Jill's AI entity game object, and I'm going to set her body damage all the way back down to 0. And of course, all we've done at the moment is we've added one audio collection player to just one state, which we've currently been using to test all of our animations. Actually, what I'm going to do is I'm going to set the idle animation on Jill's base layer back to whatever it was using before, which I think was zombie idle 1. Okay, so yeah, what we need to do now is we need to add the audio collection player to all of our other locomotion states on both the base layer and the lower body layer. And they're going to be set up exactly the same as the audio collection player on the idle state. So I don't think, unfortunately, we can't multi-select states and add behaviors to all of them in one go, which is sad, of course. So I'm going to select my zombie turn left. I'm going to add an audio collection player, but I'm going to do this for all of them first, and then I'll go back and reconfigure them all. Just adding an audio collection player to each of what I call my core locomotion states. But not including idle. I don't need one on idle, even though I've got one on idle. So strangely enough, I'm actually now going to remove the one that's on idle because I don't actually need it. none of my idle animations require to play any sounds or footsteps. But if yours do, then you are going to want to put an audio collection player on it. I've just added a root motion configurator, a second root motion configurator, instead of an audio collection player there. So let me fix that. Okay, so I've added them all to the core locomotions, which are these, on our base layer. So what I need to do now is I need to set each one of them up. So for the collection, I need to assign it our footsteps collection. And as the layer exclusions, I need to assign it our base layer. Need to do the same now for all of the other ones on this layer. So I set the collection to zombie footsteps. And I set the layer exclusions to base. You're going to appreciate scriptable objects make this one heck of a lot easier than if I had to be typing out that list of layer names for each of these states. Okay, so that's those all done. And let's go to Jill's lower body layer now and do the same thing. The idle one doesn't need them, but the turn left and turn right do. So I'm going to add an audio collection player to each of her states to start with. Like so, and then I'm going to fill them out. So for the collection of our turn left and turn right, remember this is the Romero turn on spot left and turn on spot right animations we're using here, which are pre-baked animations which need that curve that we created for it. So I'm going to, for the collection, assign it zombie footsteps. For the custom curve, I'm going to assign it our Romero turn on spot left curve that we created in the last lesson. And for the layer exclusions, I'm not going to assign it base this time. I'm going to assign it lower body. And remember, lower body is like base, except that the lower body layer itself has been removed from the list. And we need to do that for our zombie turn right as well in exactly the same way. We had the zombie footsteps audio collection. We had the Romero turn on spot right custom curve. And we had the lower body string list. For the walk, jog, and sprint animations, they don't have custom curves. The curves are all on the animations themselves. So we just need to assign the footsteps and the string list to each one. Remember, we're assigning the lower body string list to each of these states, not the base string list. Okay, so our locomotion states now are pretty much handled. So let's go back to Jill, because you will remember at the moment we've set her up so that she stays in idle forever. So we'll just put her in idle between, say, 2 and 5 seconds. We won't give her any lower body damage to begin with. Let's just see how this works. Just check all of her states are working correctly. So I'm going to press play. So she's idling, she's not making any footstep sounds, but then she's going to start to walk and we should hear some footsteps. Yeah. There she is. She's actually running to get the player there. So that works fine. Let's just check what she's like with lower body damage as well. So selecting Zombie Jill's AI entity, I'm going to push her lower body damage up to about 40-ish. Just check that all of our footsteps are working correctly. We're obviously going to have other sounds here as well, such as the zombie moaning and groaning. That's our custom curve, and then there she is with the foot drag. Obviously these sounds, I don't know what they're like on the video, but they're really loud at the moment, and you'll recall that's because I've set the footsteps audio collection to be a 2D sound at the moment, because if I didn't, my player and my audio listener is actually all the way over here in the elevator shaft, and I wouldn't be able to hear a goddamn thing. Okay, so all of our locomotion settings are done now for the base layer and the lower body layer. What we need to work on now is the attack layer, and we need to create some attack sounds and an attack audio collection. So for our zombie attacks, we've got a series of swiping sounds that we wish to trigger on these states. There are a few exceptions, such as attack 2, which is the feeding state, which will use an entirely different sound system that we'll implement probably in the next lesson. Okay, so let's set up the import settings for our zombie swipe sounds. We've already imported them into our project, and they can be found in the sounds folder in the zombie sounds subfolder, and inside the zombie sounds folder there is another subfolder called swipes. If you drill down into there are our sounds. Oh yeah. So what I want to do is I want you to select all of those swipe sounds, and I want you to make sure that force to mono is ticked. I've created these sounds, and I think some of them may have come in stereo by accident, and we don't want them to be. We also don't want these to be compressed. They're very small sounds, so they're going to be more performant if we can just store them uncompressed in memory and play them uncompressed. So we're going to set the compression format to PCM, and then we're going to click apply to save those changes. So we've got the sounds ready to use. Let's now create our zombie swipes audio collection. So we create all of our audio collections in our sounds audio collections subfolder. So with that folder selected, I'm going to go to the assets menu, the create submenu, and choose to create a new audio collection. I'm going to call this zombie swipes. I'm now going to select the zombie swipes audio collection. I'm going to make sure that I assign it to the zombies audio group. And for now, I'll set the volume down to about 0.2, kind of like our footsteps are. I'm not going to bother setting this down to 2D just for testing, because quite honestly, our zombies aren't going to be swiping at us unless they're next to the player anyway. So in fact, now we can probably select our zombie footsteps as well, and we can set its spatial blend back up to fully 3D as well. So for now, I'll set the volume of our swipes sounds to exactly the same as what our footstep sounds are, which is 0.85. And then I'm going to lock the inspector so that clicking on other assets in our project view doesn't lose the zombie swipes inspector. I'm going to drill back down into my sounds folder and into my swipes folder. I'm going to multi-select my swipe sounds. I'm going to drag and drop them over. Oh wait, I can't do that yet. I have to tell it how many banks are in it, don't I? This is only going to be one bank. Then I can drag over all my zombie sounds and drop them into bank 1, like so. So we now have our swipes audio collection. Now, because our swipe sounds are going to need to play at the same time as our footstep sounds, we don't want to use COM channel 1 to carry the command requests in via the animation curve. So we'll use COM channel 2 instead. So I'm going to add an audio collection player to all of the attacks except attack 2, because all of these are just standard sort of attack swinging and animations except attack 2. Now attack 2 is our neck bite animation, which remember is this one here. And what's kind of different about this one is it goes on sort of an intermediate. And what's different with this one is it goes on sort of an indeterminate amount of time, especially true for feeding on, for example, the cinematic layer, where when our zombie goes to start feeding, it will actually stay feeding until its satisfaction has risen above a certain threshold. So we're going to use a different sound system, what I call the ambient zombie sound system for that. So we're only going to be working on the standard lunge and punch attacks here, and we'll work on attack 2 separately. So for attack 1, we want to add a new audio collection player. For attack 3, we wish to add an audio collection player. Point me keep saying this, isn't it? We just want to add these to everything, don't we? Except attack 2. Oh, now attack 8 is a headbutt. So I'm probably going to use a different audio collection for that. I still want it to have an audio collection player on it, but whereas all the other ones are going to have swiping sounds, for attack 8 we're probably going to have some other type of sound that we play from a different audio collection of like a head hitting something, I think. But hey, you know, I'm making this up as I go along. Okay, so we might as well set all of this up now before we add the curves. Okay, so what I'm going to do is I'm going to pause the video. I'm going to do the first one, and I'm going to show you what I do. So for my audio collection, I'm going to add my zombie swipes. And for my layer exclusions, I'm going to add attack. I'm going to ignore attack 2, but for attack 3 all through to attack 7, I'm going to do exactly the same thing. I'm going to assign them the zombie swipes and assign them the attack layer exclusion list. I'm going to pause the video while I do the rest. Okay, and I'm back. So I've added our swipe audio collection to attacks 1, 3, 4, 5, 6, and 7. I haven't assigned any audio collection to attack 8 yet, the headbutt, because I don't quite know what audio collection I'm going to use for that yet. And I also haven't assigned anything to attack 2, the feeding state, because this is going to need a different audio collection and probably use a slightly different sound system other than our audio collection player, which is kind of like a one-shot sound system. Our ambient sound system that we're going to develop in future lessons is going to be something slightly more complicated for dealing with longer playing looping sounds in a multi-layered scenario. And the other thing I've done for attacks 1 through 8, excluding attack 2, I've assigned them the attack string list, okay? So all of the attacks except 2 have the attack string list, but attack 8 and attack 2 doesn't have the Zombie Swipes audio collection assigned. Now the next thing I need to do is I need to select all of these. Oh god, it really gripes me. I can't multi-select. And I need to change the command channel that the audio collection player is going to listen to from COM channel 1 to COM channel 2. And this is the COM channel that we're going to need to define our curves for our zombie attack animations so that they correctly are picked up by our audio collection player on this layer and correctly trigger the swipe sounds. Obviously, I haven't done that for attack 2 because attack 2 doesn't have a script on it yet. Forget all about attack 2 for now. That's the feeding attack. Okay, so now we need to go through all of our motion fields and we need to select the animations and make sure that we've added a COM channel 2 curve. So we'll start with attack 1. This is not a pre-baked animation, so we can add a curve to it. And if I press play, you can see this is what it looks like. It's a right-handed animation. And what's kind of annoying about this is that we already have curves defined for like the right hand and the left hand, but we can't just duplicate the curve that's already there into COM channel 2. We've got to set it up again because COM channel 2 has to, in some cases where it's a two-handed attack, has to contain both the left hand and the right hand curve. So they are kind of unique curves. So in this particular case, we need to create a new curve. We need to call it COM channel 2. And then we need to sort of scrub along and basically just recreate that right hand curve like so. So I'll create the keys first, and then I'll step back over it and set the values now. So the inner keys need to be set to 1, which is going to tell our audio collection player that's listening to COM channel 2 to play a random sound from bank 1. Okay, so that is the COM channel 2 curve created for that animation. Now, is there an easy way for me to test this without adding all the curves to everything else? Possibly. At the moment, the transition into that attack is when we're attacking, and if the attack integer is greater than 0 or less than 21. So if I just change 21 to like, I don't know, 10,000, then hopefully attack 1 will always get selected, and that'll be a good way for us to test it. Let's just make sure I turned off lower body damage for Jill. Yes, I have. And hopefully she'll come and get me now. Well, let me just check. I did set up the animator correctly, didn't I, for attack 1? Yep. Okay, let's see what happens. So hopefully she's going to come and attack me now. Oh, charming, she's running away from me. Hello, Gio, come get me, baby. Yeah, there you go. I mean, that sounds a bit rubbish at the moment. I'm kind of stuck on her, but that sounds a bit rubbish at the moment. But trust me, it's going to be quite quiet. And it's also, there's other things that she's going to be doing while she's attacking, like going, ah, ah. And you're going to be sort of going, ugh, ugh. And there's going to be also some damage sounds being played that's going to feel like the player's skin is ripping or whatever. So that's just going to be like a subtle sound. It's probably still a bit loud. So we can probably turn that audio collection's volume down a little bit more to say something like 0.3. Let's try something like that. Obviously, it all looks and sounds a lot better as well when there's multiple attack types. The fact that she's just repeating the same attack type at the moment makes it sound a bit rubbish. Yo, come get me, Gio. Come get me, baby. So here she comes. She's coming to get me. Yeah, that's cool. You see, when I hit her back at the moment, we're not getting any footsteps from those hitbacks because we haven't dealt with the hitback layer yet. There is also something I've just noticed actually. When you play like that, and I was hitting her several times, that what was happening is on the hit layer, let's say for example I hit her and I activate this animation here, and then I hit her again in that same area, and that animation is only halfway through, that animation will be re-triggered again. And that's because if I select the transition from any state into that animation, what it's allowed to do is it is allowed to transition to itself. So if we're halfway through that animation, that hit back animation, and she gets hit again in the same place, even though she's halfway through, it will start again. Now what happens, it doesn't get treated as if you've exited the state and entered it again. The enter gets called, but the exit doesn't. And that completely and utterly buggers up our root motion configurator system, because we don't get a chance to decrement the root position and root rotation reference counts. And to be honest, it looks kind of crappy anyway, because when you keep shooting a zombie in the same place, it keeps repeating the animation. So not only does it bugger up the root motion, it also shows this repeating pattern. So what we're going to do is on our hit layer, I want you to select all of those transitions. I want you to untick where it says can transition to self, all right? Because that took me quite a bit of debugging to find out why all of a sudden my characters look like they were sliding. It's only the ones from any state, isn't it? So you just want to make sure that none of these transitions have can transition to self ticked. Okay, so what I'm going to do now is I'm going to create all of the rest of the curves for my attack animations. I want you to pause the video and do the same thing, all right? Because it's pointless you just watching me while I add curves to all of these animations. Of course, I'm not adding them to attack 2 yet because that's going to be handled slightly differently. And when I unpause the video in a minute, I'll just show you some of the curves to some of the more tricky two-handed attacks so that you can cross-reference them with the curves that you've created. Okay then, and I am back. So let's have a look at some of the curves that I've added. I didn't add one to attack 2. For attack 3, it looks very much like the right hand attack, which is just used to know when the zombie is doing damage. And you'll find this with a lot of these attacks. The shape of the COM channel 2 curve, which is triggering the sound effect, is going to mirror very much what is either in the right hand or the left hand curve. So if I call up attack 4, for example, where this does a left-handed and a right-handed attack, you can see it's slightly different because our right hand in this animation does damage to the player, but only because the zombie is kind of grabbing the player by the throat there. So we shouldn't make a swipe sound there, but we do make a swipe sound about there when the second hand comes through to swipe down. Let's open up attack 5. This is another two-handed attack, so you can see that looks very much just like what the left hand and right hand curves look like combined. Attack 6, kind of a similar thing again, really pretty much just mirrors the left hand and the right hand, kind of a combination of them both, but being sent to COM channel 2 parameter. For attack 7, just really a combination of the right hand and left hand curves. For attack 8, which is the headbutt, I've still put the curve in there on COM channel 2, which mirrors the mouth damage curve, but I don't know what sound I'm going to play there yet, but it'll probably be some kind of like headbutt sound or some kind of sound or something. So that's all of my curves done. Hopefully yours look something like that. So what I can do now is I can test these. Of course, while I'm testing this, if the feeding one gets selected by random, then we're not going to have any sound for that. And we're not going to have a sound for attack 8, the headbutt either, because I haven't created the audio collection for that yet. But of course, what we did do is we just messed with the attack random number generation by altering the transition into attack 1 by setting attack is less than 10,000. We need to put that back down to attack less than 21 again. Okay, they all seem to be working. Now, I know those swipes sound kind of weird at the moment. They're literally just supposed to be like swipes of air, okay? And at the moment, we're hearing them too pronounced because in the game, there's going to be all sorts of other stuff going on in the game. So at the moment, they sound a little bit exposed and a little bit fake. But trust me, when they're in the Creeper game and we've got sort of all the other stuff going on in the background, I think that volume will probably be okay. Okay, so that's pretty much our attack layer done for now. When we come back in the next lesson, we'll probably be able to finish off all of these other layers and have them making all of their one-shot sounds. And then in the lesson after that, we're going to create this thing that I call a layered audio source, which is going to be used for all of our ambient zombie sounds, things such as the kind of moaning and groaning that the zombies make when they walk around the level. It's also going to be reused by things such as the feeding sound, various cinematic sequences, and also I think I use it for screaming as well, I think. I'll have to just check that before the next lesson. Okay guys, well thanks for listening. I will see you next time, and hopefully before too long we'll get this sound stuff out of the way and get on to something more interesting. But as I said at the beginning of this section, there's quite a lot to adding sound to your game that you don't really appreciate at first. You think you can just pop a few audio sources in the scene and you're done, but when you really need to get all of this stuff synced up with your animations, all hell can break loose, and we're not there yet either. Thanks for listening guys, I'll see you next time. Bye bye now.